What's poppin', dogs? Mr. Allen here with some simplifying of radical expressions. But look out, man. We got ourselves negatives inside of all four of these square roots. So what in the heck are we going to do? We got to use imaginary numbers. Well, what the heck is an imaginary number? Well, our imaginary number, I, equals the square root of -1. Okay? So really we can think about these things here. I'm going to break down the first one, and then I think you're going to kind of get the pattern. I could break this apart into the square root of -1 times the square root of 81, right? If they're both inside the radical, I can multiply them together, and they stay inside the radical. Did you hear Jenny there? She was shaking, right? You hear the little collar jingle. Anywho, so I can break them apart in the same way, right? If I had two radicals, I just multiply them together. They can go into the same radical. I can break them apart as well. So now I just have I times the square root of 81, right? Because I said that the square root of -1 equals I. And what's the square root of 81? It's 9. So now I'm going to have I times 9, but really we're going to write that thing as 9I. That's how we're going to write it. Okay, the I is going to come after that number, that coefficient, if you will. Cool? So there's the first one. Already done, baby. Already done. 9I. So now when I go through these, what I like to do is I'm just going to ignore the negative in there. I know that I is going to come out. I'm going to break these down exactly as I would if they were positive numbers. So if I break this down, I like to go with 2's until I can't. That's how I go about it, right? Or you can look for perfect squares, but most of my students, they like to do the prime factorization. So I'm going to divide by 2, and I got 40. Divide by 2, 20. Divide by 2, I got 10. Divide by 2, I got 5. Woo! It's a long factor tree. Got a pair? Got a pair. So how's this final answer going to work? Well, I got 2 times 2. It's 4 is going to come out, so equals 4. I have the 5 is going to stay in, but that negative will come out as an I root 5. Beautiful. All right. Next one up here. I got a coefficient out front, a 3 out front. How do I deal with that? I'm going to break down the -20 just as I did here. Then I'll multiply the stuff to the 3 that comes out. Okay? So let's break it down. I got, 2 and 10, 2 and 5. I got a pair. Boom, that comes out. So that's going to be 2 times 3 is 6. The 5 can't. It's going to stay in the radical. The negative, that's my I, root 5. Beautiful. All right, I should switch colors here, man. It's getting all the same color. Go orange for the last one. So same idea as this one here, right? I'm going to break down the 48. Whatever comes out multiplies to the 7. An I comes out. Other stuff stays chilling in the radical. So I got 2, 24, 2, 12, 2. We got 6 and 2, 3. It's a bunch of 2's once again. 2 times 2 is 4. Times 7 is 28. And I comes out because of the negative. And then the 3 stays in. Root 3. Final answer. Boom. We're done, baby. So that's the only difference there. If there's a negative in the root, I can take that out. If it's a negative in the square root or an even root, I can take that I out. Everything else works the same as if you were just dealing with real numbers in the way that you simplified radicals in the first place. All right, guys. So hopefully that helps. And, stick around, watch more dope videos, and have a wonderful, fantastic day. See you later.